This will just be a quick demonstration of every feature on my Eurorack modules. I'll walk you through how they work, starting with a quick look at the standard Eurorack power connection, making them compatible with any Eurorack system. Now, let's turn everything on and dive in. This is the MIDI clock divider. It has 3 columns, representing triplets, standard, and dotted note divisions. This switch lets you choose between an internal clock and a MIDI clock. When using the internal clock, this tempo knob controls the speed. There's also a speed selector that allows you to extend all gate lengths, making them 2 or 4 times longer. The module receives the standard MIDI beat clock via the MIDI input, and when I connect it to Ableton, in this example, and hit play, the clock will be synced to Ableton. The reset input allows you to reset the clock from another module or from one of its own gates. If I send the whole note gate from the clock divider to the reset input, you'll see that it resets the clock every whole note. And with the reset output, I can reset other modules in my setup, keeping everything in sync. Next up is the permutational sequencer. It has 3 gate inputs, and the combination of these inputs determines which step controls the output. I'll start by connecting a simple 8th note gate to each input individually so you can see how they interact with the sequence. The front panel colors, yellow, red, and teal, indicate how each input contributes to the step selection. Now, when I connect multiple gates together, they combine to access all 8 steps. With different gate patterns from the clock divider, the sequence becomes more dynamic and interesting. Especially combinations with triplets and dotted notes result in some interesting sequences. But of course, you're not limited by the gates from the clock divider. The sequencer will take any gate signal. There's a range selector that lets me choose the output voltage range and a level knob to attenuate the output signal. Additionally, the module has a trigger output, which generates a trigger signal every time the step changes. Finally, let's look at the quantizer. It has 3 control voltage inputs and 2 independent voice outputs. If I send the control voltage from the permutational sequencer into the quantizer, I can blend it into each of the 2 voices using these mixer knobs. When I enable specific notes in the scale, the module starts playing only those notes. Each voice has a standard CV gate output with a 10-octave range, from 0 to 10 volts. Let's connect a synthesizer to the CV gate output of voice 1 so we can hear it. Any input without a cable connected acts as an offset for that voice. You can also connect gates from the clock divider directly to the CV inputs of the quantizer. If I connect a MIDI device to the MIDI input, I can control which notes are active in the quantizer. Right now, I'm sending a simple chord progression from Ableton, and you can see how the notes change in real time. There's also a MIDI output that sends the notes from each voice on 2 different channels. That means you can connect it to your hardware or software synthesizers to play the notes of voice 1 and 2. Watch as I connect the MIDI output to Ableton. It's now playing the second voice. It also sends the scale information as notes on another channel, so you can receive it with another one of these quantizers, so you and your bandmates are always playing in the same key. Each voice has a duration knob to control the note length. The optional trigger inputs give you some more control over when a note is played. This can be used, for example, if you have a sequence with repeated notes that would not trigger the quantizer otherwise. Lastly, you can change the MIDI channels by holding these buttons for a few seconds. There is a channel for voice 1, the active scale, and voice 2. The scale is set to channel 16 now, but by pressing this button, I can cycle through all channels. And that's a quick demonstration of all features. Thanks for watching.